Let's solve our example number 2 of section 12.7. So we have a boat that travels a circular path of radius r equals 4 meters. And the speed of that boat is 0.0625 t square meters over second. So we want to find the magnitude of the boat's velocity and the acceleration when it has happened 10 seconds. So the solution, so we start by finding our velocity. The expression of the velocity is given, 0.0625 times square. So if we want to find it for t equals 10 seconds, we just substitute the 10 seconds square, and then we get a velocity of 6.25 meters over second. So that was easy. What we have to know, this is in magnitude. If we want to write it as a vector, we need to know the direction. So as a vector, our velocity is always tangent to our path. So it will be 625 in the tangent direction. What is the tangent direction? So the tangent direction will always be tangent to the path. This is a unit vector in the tangent direction, and this is a unit vector in the normal direction. So our velocity is always tangent to the path. So this is our velocity, which is equals to 6.25 meters over seconds for that time 10 equals 10 seconds. Don't forget the units. It doesn't matter if it's a scalar, which is the speed, of as a vector, we need to put the units. How about the acceleration? So we know that our acceleration, whenever we have a curved path, we have two directions in our, two components in our acceleration. We have our tangent component and we have our normal component. The tangent component, we know that is the derivative of the velocity, and we have the expression of the velocity. And the normal component, we know that is the velocity squared over the radius of curvature. So if we want to find the tangent component, we have to derive, respect to time, the expression that we were given, which will be 0.0625 times 2t. Substitute for t equals 10 seconds. We got that our tangent acceleration will be 0.0625 times 20, right? And that gives us an acceleration of 125, right, meters over second square. How about our normal acceleration? So the normal acceleration is just the velocity squared over our radius of curvature. The velocity we already calculated for t equals 10 seconds, right, which is 25 square, and the radius of curvature is the radius of our path. Since it's a circular path, that radius is constant through all the path over our boat. So it will be 40 meters. So, and that gives us our result of 0.9766. And then this is a 0. Since we already have the tangent component and the normal component, write our expression of the acceleration in terms as a scalar or as a vector. To write it as a scalar, we need the magnitude. So the magnitude over acceleration will be t squared plus n squared. That is the square root of 1.25 squared plus 0.9766 squared. And that gives me an acceleration of 1.59 meters over second squared. As a magnitude, if I want to write it as a vector, I will have 1.25 in the tangential direction and 0.9766 in the normal direction. And I have to also write the units, either if it's scalar or vector. So we got the magnitude of the both velocity and acceleration for time equals 10 seconds, the velocity as scalar as a vector, and the acceleration as a scalar and as a vector.